In the last section, we collected our data and we organized it. And now we're going to measure our data. We're going to look at what we call our measures of central tendency in this section 12.2. So measures of central tendency are our typical measurements. The reason why it's called central tendency is it's the tendency of our data to cluster around the middle. An example of typical measurements would be an American male, 31 years old, 5 feet 10 inches tall, weighs 172 pounds, works 6.1 hours a day, and sleeps 7.7 hours per night. Now, there are 4 types of measures of central tendency. The 4 types will be the mean, the median, the mode, and the mid-range. And usually we want to look at all of these when we talk about our data. We don't want to base our results on just one measurement. Let's look at the first one, the mean. And this is what you know in mathematics as the average. So when you wanted to find the mean or the average test score on the scores below, just remember what we do when we find average. What we do is we add up all the items. So we're going to add up these 4 test scores, and then we divide by how many we have. So the mean is just 69 plus 76 plus 84 plus 91 divided by how many we have 4. So that should give me 320 over 4, which is 80. So that would be the average test score. In statistics, we often use symbols to represent our mean. I don't know if you've seen this symbol before. If you work with spreadsheets, you may have seen this. Weird symbol, this is our sigma. And a sigma means add or sum. So this is a Greek letter, and it just means to sum. So if we were to sum all of our data items and divide by how many we have, that brings us to our mean formula that you will see in your textbook. So just remember, formula is not scary. All it means is you're going to sum your data items and divide by how many you have. So we saw our sigma notation. If we let the x in this formula be the data item, then this says sum the data items, and then n is going to be the number of data items that you have. So I'm not going to be using that formula. I'm just going to do what you saw. I'm just going to add them all up and divide by how many I have. I just wanted you to be aware of that notation if you see it in your textbook or in my lab. In example 1a, we want to find the mean for the group of data items. So again, all we're going to do is add them up, 10 plus 20 plus 30 plus 40 plus 50, and then divide by how many we have, and we have 5. So this becomes 150 over 5, which is 30. In part B, we have a different group of data items. We still have 5. So if I was going to find the mean for these, again, I would just add them up. 3 plus 10 plus 10 plus 10 plus 117. Divide by 5, and I get 150 over 5, which is 30. So these 2 groups of data items in part A and part B, they had the same mean, but look at the data items themselves. They're very different. So example 1A, those data items are pretty close together, 10, 20, 30, 40, 50. And their mean is 30, right? So the average is 30, makes sense. But in part B, we have a 3, which is very small, a bunch of 10s, and then 117, which is really large. So the mean is still 30, it's still the average, but it's not giving me the full picture of my data, because I can see that if I were to ignore the smallest and the largest, I have a bunch of 10s. So the mean is not enough when we measure data. We're more measurements. But first of all, what we're going to do is remind ourselves that we already got data and we already organized it. So let's just say that we have a frequency distribution. We have our data organized in a table. And let's say that we wanted to find the mean, but it's already in a table. So remember what this is saying for this first row. It's saying for the data item of 30, I have 3 of those. So that's the same as 30 plus 30 plus 30. But isn't that also the same as 30 times 3? So if your data is already organized in a table, you can just multiply across in the rows. And 30 times 3 would just be 90. For the next row, I have a data value of 33 and I have 4 of those. So I could do plus 33 4 times. And already I'm getting tired of doing this. Or I could simply multiply across, and 33 times 4 should be 132. So if we continue just multiplying across, 40 times 4 should be 160. And then 50 times 1 is 50. Okay, so remember, we were supposed to add up all our data items. So the final step here when we add up or sum all our data items would be to total 90 plus 132 plus 160 plus 50. Add all these up and we have 432, unless I did my math wrong. Okay, so I have the sum of my data items. So how many data items do I have? Well, that just comes from your frequency. If you add up the frequency column, 3 plus 4 plus 4 plus 1, that's going to total 12. So that would be the n, the number of data items that you have. So we're going to divide 432 by 12 to get 36. Now you don't have to use the table, but I mean it's already organized in the form of a table, so why not? Yeah, you can always just write it all out like I did at the top. This brings us to the next formula we have that would probably show up inside your MyLab or your textbook. And that's calculating the mean if you already have a frequency distribution, if you already have a table. So remember this sigma notation, that just means sum. So we're going to sum or add. Here x is our data value, but f is the frequency. So xf is simply what we did in the table. It's data value times frequency. So we're going to sum up the data values times the frequency, which is how we got the 432. And then we divide everything by n, the number of data items. So this is our mean, our average. But remember, we have 3 other measures of central tendency. So the next one we're going to talk about is just the median. And the median is, think about driving. You have the median strip, that's the center. So that's what the median is. It's your middle data item when the items are in order. So they have to be in order from smallest to largest. So if they're not, the first thing you're going to do when you find your median is you're going to arrange the data items from smallest to largest. Once that's done, if you have an odd number of data items, then the median is just the middle data item. However, if the number of data items is even, you're going to have 2 data items in the middle. So what you do is you take the mean of those 2 middle data items. So just add them up, divide by 2. In example 3a, we want to find the median for each group. So first of all, 28, 42, 40, 25, 35, these are not in order from smallest to largest. My first step is to put them in order. So that would be 25 is the smallest, 28, 35, 40, and 42. So now that I have them arranged from small to large, I can see that my middle, which is 35, would be my median. And notice I have an odd number, so it is that middle number 35. In example B, it's not in order. It looks like 61 should be the smallest, and then 72, 79, 85, 87, and then 93. Now my data items are in order. I have an even number though. I have 6 of them. So I'm going to have 2 middles. That would be the 79 and the 85. So I'm going to have to take their mean and take 79 plus 85, divide that by 2 to get 164 over 2, which would give me 82. That would be the median. So let's say that you have a lot of data items, okay? And they have to be arranged from smallest to largest. One way that you can identify the middle, and you don't have to use this formula, but this is an alternate formula to find the median or the middle, is, again, make sure you're from smallest to largest. So the median is the value in the n plus 1 over 2 spot, assuming that everything's arranged small to large. Remember, n is the number of data items you have. In example 4, I can clearly see that these data items are already arranged from smallest to largest. So I need to count how many I have if I were to use this formula, which I will. And I have, it looks like I have 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so I have 19 items. That's my n. So to figure out which one's in the middle, I could use this formula if I want, or I could simply count to the middle ones. Now it's an odd number, so there's only going to be one middle. Let's see, so this is going to be 19 plus 1 over 2, 20 over 2, 10. So the 10th data item should be my median. So I would just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I see that 5 is going to be my median. Try another example. In example 5, listed below are the numbers of home runs for each of the 14 baseball teams in the American League in 2005. So we want to find the median number of home runs for these teams. Now I'm going to scan it, and it looks like they're all from small to large. So my median would be the middle. I could use the position to figure out what the middles are. I have 1, 2, 3, 4, well, it says 14. So I don't even have to count these. Since my n is equal to 14, then the median will be at the 14 plus 1 over 2 position. And then 15 divided by 2 is 7.5. So that tells me I go to, it's going to be between the 7 and the 8. Okay? And that's because I have an even number. Remember, when you have an even number, you have to take the mean of the 2 middles. So I'm going to have 2 in the middle. They're going to be in the 7 and the 8 spot. So 1, 2, 3, 4, 5, 6. And then I'm going to look at these 2. Now if I take the mean, it's 157 plus 168 over 2. And then that turns out to be 162.5. That would be my median. Well, what if everything's organized in a frequency distribution? Remember, we want to find the middle. Once it's arranged in a frequency distribution, remember the data value should be arranged from small to large, so everything is arranged from smallest to largest. In this particular example, I noticed that the total number of data items I have is 18. So I know my n is equal to 18. I'm going to use the position formula to find the median. The position would be 18 plus 1 over R2. So that's going to be 19 over 2. Gives me 19.5. So I'm looking at position 9 and position 10. So how can I tell which one that is? Well, let's look at the table. In this first row, I have the data value of 42. I have one of those. So that would be position number 1. In the second row, I have a data value of, 43, and I have one of those. So I have a 42 and a 43, so this should be my second position. All right, so let's look at the next row. 46, I have one. So this would be my third position. And you could see something weird happening with my pen. Sorry about that. This is the third position. And you could see if I were to list out the data items, I have 142, 143, 146. At 51, I have 3 of those. But I don't really want to do this. It's all organized so nicely. So remember, this was position 1, 2, 3, and then I have 4, 5, 6 for the next row. I have 3 of these, which would be position 4, 5, and 6. So all I had to do really was take this 3 and add it to the 3 that came before to get 6. So that's going to be positions 4 through 6. In the next row for the data value of 51, I have one of those. So I ended off with position 6. This must be position 7. And we were looking for position 9 and 10. Next row, I have 54. I have 2 of those. So if I ended off in position 7, then this must be position 8 and position 9. Okay, so remember, I was looking at position 9 and 10. So it looks like 55, I have 2 of those. That would be position 10 and position 11. So 54, the data value of 54 is in position 9. The data value of position 10 is that 55. So remember, what we're doing is we're actually adding up the data values, not the frequency. The data item of 54 and the data item of 55 is what we're adding up, and we're taking their mean. So that would give me 109 over 2, or 54.5. This would be my median if I already have my data organized in a table. So one last example of median. Example 7, there's 5 instructors at Windward Community College, and they earn annual salaries of $50,000, $53,000, $56,000, $62,000, and $64,000. So the former athletics director of UH Manoa earned $240,000 per year. Part A, we want to find the median annual salary for the 6 people. So remember, the median says, and there's 6 of them, so there's going to be 2 middle ones. The median says if there's an even number, you take the 2 middle and you find their mean. These are organized in order, so the 2 middle should be the 56,000 and the 62,000. So if I add them up and divide by 2, I get 59,000. And I need to put the $sign on there. So that would be the median annual salary. for those people. So part B, and did it again. Part B, if we wanted to find the mean for the 6 people, remember we're just going to add all these up. 53,000, 56,000, 62,000, 64,000, and then the last one was 240,000. We're going to divide by how much we have, which is 6. I'm just going to shove that in a calculator to get, and I'll put it down here, 87,500. Okay, so notice that these two values are very different because we're using different measurements. Now, if I had an advertisement and I said that, oh, we're hiring a position at Windward and the typical salary is 87,500 per year, I would not be lying. But when you look at these people, most of the people in this particular example are actually not going to make that amount, right? The average salary would be more representative by looking at what we found in A with the median annual salary. So you do have to be careful when people are throwing statistics at you. You want to know how they measure their statistics, because if they use the median, which is usually what they use when they're looking at the average sale of a house in your neighborhood, say, they look at the median value, and that's not the mean, that's not the average. So sometimes, and this happens quite a bit, people will skew the data so it favors their position. Moving on, we'll look at our third type of measurement, and that would be the mode. So the mode is really easy to find, even though in that box it seems pretty long. All it is the data item that shows up the most. That's it. So the mode is the data value that occurs most often. So it has the highest frequency. If no data value repeats, so if all the data values just have a frequency of 1, they don't repeat, then there is no mode. If more than one data value has the highest frequency, then there's more than one mode. So there could be more than one mode. In example 8, we want to find the mode for the following group of data items. So when we find the mode, it doesn't have to be from smallest to largest. We're just looking at, does any of our data items repeat? And if so, which one repeats the most times? Which one has the highest frequency? So I could see that I have 8, there's 3 8s. There are 2 6s, but there's more 8s than there are 6s. So the mode is actually 8. It's the data item with the highest frequency as long as it repeats. In example 9a, 8, 6, 2, 4, 10, none of those repeat. So this is an example where there is no mode. In example B, we have an 8, 6, 2, 4, 6, 8. So the 8 repeats, there's 2 of them, and the 6 repeats, there's 2 of them. So since they have the same frequency, we have 2 modes. We have 6, we also have 8. So it's possible for there to be one mode, no mode, or many modes. And that's all we're going to talk about with mode. Very simple. Let's look at mid-range. Mid-range is our last measurement. So when we talk about the mid-range, all we're doing is we're taking the lowest data value, adding it to our highest data value, and dividing by 2. So we're finding the mean of our smallest and our largest data item. In example 10, 2008, the Oakland Raiders had the greatest payroll of any team in the NFL. So the payroll was roughly 152 million. The Kansas City Chiefs were the worst paid team, and their payroll was about 83 million. So we're going to find the mid-range. And the mid-range is what we sometimes use if we want to know. So if we were looking at the Warriors, and we wanted to know what the annual pay was, then we can kind of compare it to the mid-range and see if we're above or below that mid-range. So it's a nice way to see where you fall. Let's see, adding these up, we have 1, 5, 2, 3, 8, 9, 3, 7, 1 plus the 8, 3. Notice I put the highest first just because that's the number I saw first. Since the numerator in this formula is an addition, it doesn't matter if you're taking the lowest plus the highest or the highest plus the lowest. You're still going to get the same answer. I got, and it's a dollar amount, 118, 006, 573 point, and I'll write a dollar amount. I'll do 0.50. Usually, if it's already rounded, we would round this up to a 4, so it should read 574 at the end, but I'll just keep it that way as a dollar amount with 2 decimal places. So this is our mid-range. So if you wanted to look at the payroll for other NFL teams and compare it to the mid-range, if their payroll is above that mid-range, pretty good. If it's below the mid-range, not so good. Our last example, we're going to compare all of them. So let's just say that you have 4 exam scores in a course, and your exam scores are 51, 66, 66, and 97. So part A, without even performing any computations, would you like your grade to be determined by the mean, the median, the mode, or the mid-range? Well, right away I could see that probably not the mode, because here the mode is 66. And I see that 97 in there. So I'm thinking, well, maybe the mean, possibly the mid-range. What about the median? Well, remember, the median is the middle. Since there's 2 in the middle and they're both 66, when you add them up and divide by 2, you still get 66. So without doing any computations for part A, I could see that I probably would want to go with the mean or the mid-range, because the median and the mode are both going to be the same, 66. In part B, compute your final course grade using the mean, the median, the mode, and the mid-range. So their mean would be, well, actually, let me do the mode first since that's easy. The mode is 66. It's the data item that shows up the most. And I could see what the median is too. Oops, sorry. I was going to do mid-range, but median. The median is also 66 because we have the 2 middles. Add them up, divide by 2, you get 66. Mid-range is easy to find because all we're doing is adding the smallest plus the largest, divide by 2. That gives me 74. Okay, well that's better than a 66. Last one would be the mean. The mean would be the 51 plus 66 plus 66 plus 97, and then you would divide by 4. I guess I get 70. So it actually looks like the mid-range would be the best way to compute the course grade for this particular set of data items. That's it for this section. Now we're going to move on to other measurements in our next section. And then just a couple more sections after that, and we'll be done with our chapter 12.